This time we're going to be demoing the StreamNative Agent Engine. But before I go ahead and execute the agents to start doing their work, let's talk about our example use case. Let's take the example where you get an automated error message that the backlog is forming on a subscription for one of your topics. This would be the equivalent of like a PagerDuty message coming in. If you were to try and solve this manually, you might go through the following troubleshooting steps, where you maybe verify the topic stats that the problem still exists, refer to a run book to get ideas on how you might fix it, how people have fixed it in the past, create a plan, and then execute that plan and verify that the solution or the actions you've taken have solved the problem. But we want to automate this entire workflow. We're going to take these 4 troubleshooting steps and create 4 separate agents out of them: an enrichment agent, a data gathering agent, a planning agent, and an execution and verify agent. To start off the whole workflow, we're going to connect these with topics, and that first topic is going to be the error message coming in, which is going to be read by Agent 1. Agent 1 is going to output the original error message along with the statistics of the topic that have been gathered using an MCP server, as we've already discussed. That message from topic 2 is going to be picked up by Agent 2, which is going to use a knowledge base with all of our run books to data gather. That data is then going to be compiled and written out to topic 3, which is going to be picked up by Agent 3, which makes a plan. Once the plan has been completed, it's going to output that plan into Agent 4, which is going to execute the plan and verify. Since execution requires making changes to the server, it's again going to use the StreamNative MCP server. And finally, we're going to output the actions we took and the final results into a 5th topic. And what's really exciting is we get to see this entire workflow working today. We already have the StreamNative Agent Engine running in the background with our 4 agents that we just discussed. I also have the MCP server running so we can execute commands against our StreamNative cluster, as is required by 2 of our agents. And then I also have a Postgres database with pgvector running, and it's filled with all of the information from our runbooks, so we can come up with a plan. It's time for us to write our error message to the first topic to kick off this entire flow. So here on the screen, I have a message. There's a subscription backlog for a partition topic backlog demo in a certain instance and cluster. This message should get picked up by the first agent, which is going to follow the agent prompt to enrich that data with the topic stats. So I'm going to execute that message, and then as we go along in the demo, the 4 windows on the right are going to start to show the outputs of the output topics. But I'm going to follow along the flow on the bottom, and each time we go through an agent, I want to briefly look at the prompt before we look at the output. Let's go ahead and kick off that initial message, which should go into Agent 1. Once that message publishes, Agent 1 is going to pick it up, and this is the prompt that it's going to use to enrich the message with the topic stats. I'm going to just go through this briefly, but it says you are a Pulsar topic data collector to collect data from the system responding to handle alerts, incidents, tickets, and other issues related to Pulsar topics. Your task is to read the incoming alert, incident, ticket, or issue. Based on the symptom, you will need to collect topic stats to assist the user to troubleshoot and mitigate the issue. Once you've collected the data, use the data to enrich the original symptom and summarize it in a human-readable format. As you can see, multiple windows already have messages coming in, but the output of that first agent is this box here. And you can see that the message that came through as the output of Agent 1 is a subscription backlog has been observed for the partition topic, showing a message backlog of 1,000 messages. And part of that message now includes the current statistics for that topic. That message will then be the input to Agent 2. So now's a good time for us to look at the prompt for Agent 2. For the second agent, the prompt is you are an expert system operator responding to alerts, incidents, tickets, and other issues. You don't have any available tools, but your job is to read the incoming alert, incident, ticket, or issue, summarize the symptom, and use the KB query tool to find the relevant runbooks for the alert, incident, ticket, or issue. And then based on the runbook, provide a detailed recommendation for investigation steps that can use the provided tools. Don't include any steps that can't be done using the provided tools. So the output message from our second agent will go into a topic, and let's go ahead and look at the results of that prompt. So in our results for the second agent here in the top right, you can see that the message says a subscription backlog of 1,000 messages exists for the Pulsar topic backlog demo. There's recommended investigation steps to use the Pulsar admin subscription to verify the status of subscriptions, use tool Pulsar admin topic to get detailed stats, use Pulsar admin namespace policy to check policies, and things like topic level policies as well. Each step above uses information and actions that can be performed with the provided tools as we were hoping for. Next, we need to come up with an actual plan. That's the job of Agent 3. Let's take a look at Agent 3's prompt. So for our third agent, our prompt is, you are a Pulsar diagnostic expert, and you'll be given a pre-processed report of a given user issue, which includes the summary of the system and the recommended investigation steps. Should always identify the instance and cluster, follow the recommended investigation steps, and then one step at a time, one tool at a time, never call more than one tool. You'll always try to use the tools recommended in the investigation steps to investigate the system. But in the end, we should end up with a summary of the investigation results, current symptom, and the confidence level of our diagnosis. Investigate the steps you took, include the investigation steps you took, include a root cause analysis, and for each step, clearly describe what to do and what to expect in natural language, and only output the highest confidence scenario and steps to fix the problem. But we're not actually executing it. So at this point in time, you would be able to add human in the loop if you wanted, or depending on the confidence level of whether or not the final agent should take these steps and actually make changes to your system. Let's look at what this investigation report looks like. So in our third window here, we have the summary of investigation results and current symptom. There's a backlog of 1,000, no active consumers, no throughput, no unactive messages, and no indication of message redelivery. There's a Pulsar function, though, that we've now found that's not running. There's no namespace level retention policies, and the namespace does not have backlog. So it's taken all of the recommended actions to further investigate and now executed those to investigate and put them together in a report. The root cause analysis says that there's a backlog existing because the Pulsar function, which is responsible for consuming messages from this subscription, is not running. So the highest confidence scenario is that the function that consumes from this subscription is stopped, undeployed, or with no active consumer. The recommended step is to restart this function. Let's take a look at our fourth and final agent's prompt, and then we'll look at the final result. Our final agent is told that it will receive a diagnostic report containing an issue summary and symptoms, investigation steps, root cause analysis, and recommended actions. And the resolution process should follow the think, act, observe cycle to execute each step from the recommended resolution steps. At the end, we want a resolution summary, a detailed resolution steps, the detailed resolution steps, resolution metrics, and any final recommendations, and any technical context. So let's take a look at the output of this prompt based on the input message. As the output of our fourth agent, we end up with a resolution summary. We get a recap of the original issue. Here we have a backlog of 1,000 messages, and the resolution was that the function !! was restarted, allowing it to then resume consuming and processing all the backlog messages. The status here is fully resolved, and we get a detailed list of resolution steps, verifying function status, etc. So what we've shown now is that you can go from producing a single message into the initial issue topic. That could be an error message, for instance, from a PagerDuty alert. We were able to enrich the message with topic stats, do queries on a knowledge base to gather further information about what steps you might want to take to resolve it, put together a plan, and since our confidence level was extremely high, it automatically went into executing the solution and verifying that the problem has been resolved. With StreamNative Agent Engine, we've shown these multiple agents that can accomplish complex tasks in a fully automated way. Agents are able to take action using MCP, and all intermediate steps are written to topics, making it fully auditable. We hope you're just as excited as we are with what we can accomplish with the StreamNative Agent Engine.